All right, POE students, this is the last problem in these heat transfer problems. And that's problems numbers 25 through 29. And again, you will notice that this is an A problem, which means if you want to get an A in the class, you need to be able to do this kind of a problem. Okay, so it says a piece of aluminum metal, and I just wrote the word aluminum down here in this container. This looks like a beaker or a container full of water, and then a piece of metal is placed. This piece of metal has a temperature of 90 degrees Celsius while it's sitting outside, so it'd be like out here, and then it gets placed into the water. And the water is 4 liters. We're interested in the mass of this water, which is 1 kilogram per liter. And the water started out at 25 degrees Celsius. So this started out at 90 degrees Celsius. The water started out at 25 degrees Celsius. Okay. It was 4 kilograms. The final temperature is 28.2. So when the hot piece of metal, this piece of metal at 90 degrees Celsius, goes into the water, psh, okay, it sizzles, steam's given off, and the water temperature goes up from 25 to 28.2, okay, and the metal temperature goes down from 90 to 28.2. So the temperature final for both the metal and the water is 28.2 degrees Celsius. The specific heat of the water is 4,184 joules per kilogram per degree Celsius. The specific heat for the aluminum is 900 joules per kilogram per degree Celsius. And the question is, what is the mass of the aluminum? Okay, so let's just write down everything we know. There are 2 things that we're going to need to know for this problem. One of them is what's happening with the water, and the other is what's happening with the aluminum. Okay, because remember, the aluminum temperature went down, the water temperature went up. So whatever heat was gained by the water was taken from the aluminum. Okay, so the water has a mass of 4 kilograms. What else? We know the specific heat of the water is 4,184 joules per kilogram per degree Celsius. We know that the temperatures, this is what we need here, the temperature at the start, that says start, doesn't look like it, but it says start. At the start for the water was 25 degrees Celsius, and then the temperature at the end for the water and for the metal is 28.2 degrees Celsius. So we can do something here right now and find the temperature difference, because that's what we're going to need to know for this, is the temperature difference. So we can take 28.2, subtract 25, and we get 3.2 degrees Celsius. Okay, this is our, what we call our delta T. Okay, that's an important number. Let's get rid of that. And what do we know about the aluminum? Okay, the aluminum information from the top. We are looking for the mass. Okay, that's what we know we're looking for. So the mass, we don't know what it is. The specific heat is given here, or appears 900 joules per kilogram per degree Celsius. The temperature at the start for this is 90 degrees Celsius, and the temperature at the end is just like the water, 28.2. They're both the same temperature. So we can calculate our delta T, our temperature change, by subtracting 28.2 from 90. 90 subtract 28.2, and we get 61.8. 61.8 degrees Celsius. Oh, I don't want that. 61.8. Okay. On the unknown values, well, the only thing we don't know is the mass of the aluminum. Select our equation. So our equation that we're using for this is our heat equation. Okay, and we know our equation for heat is the heat energy equals the mass times the specific heat times the change in temperature. Okay, so that's why we're looking for all this information up on top here with the mass, with the specific heat, and the change in temperature, mass, specific heat, change in temperature, because we're going to put it into this equation right here. But this is a little bit different kind of a problem. This is why it's an A problem, is because we are going to use the idea that the heat gained, okay, so the heat gain by the water is equal to the heat loss by the aluminum. Okay, so, and that's true, because again, when you put this piece of metal right here, you put that piece of metal into the water which was 25, the metal which was 90, the water is going to heat up, okay, and the aluminum is going to cool down until they get to be the exact same temperature. So that's why we have this idea here, heat gained by the water equals heat lost of the aluminum, because the water got its heat from the aluminum. So we're going to use this equation. We're going to say, let's change our color here just to show you that our Q, our heat, equals mass times specific heat times change in temperature. That's for the water, equals the mass times the specific heat times the change in temperature for the aluminum. Okay, both of these equations, it's like saying Q equals Q, because Q right here is the specific heat, and here's the equation to find for Q. So we just use that equation there for the heat lost and there for the heat gain. So now let's put our values in. Okay, so our mass of our water, again, I'm just taking these numbers now from up here. The mass of the water was 4 kilograms times the specific heat of the water, 4,184 joules per kilogram per degree Celsius, times the temperature difference. Remember, it started out as 25 degrees. You put the metal in, the temperature went up to 28.2. So we subtracted those two, and we got our change in temperature was 3.2 degrees Celsius. That's the heat gained by the water equals the heat lost by the aluminum. Mass, we don't know, times specific heat is 900 joules per kilogram per degree Celsius, times the change in temperature for the aluminum. Remember, this is coming from up here, okay, up on the top right here. I already did it. 90, it started out at 90, we put it in the water, it went down to 28.2. We find the difference between those two. 90 subtract 28.2 is 61.8 degrees Celsius. So we put all of our numbers in here now. So we just need to solve for these. Okay, so we can isolate. We need to isolate the mass right here by itself, and the way we can do that is since it's multiplying here on the right hand side, we're just going to divide everything over here by the numbers we have. 900 joules per kilogram degrees Celsius times 61.8 degrees Celsius. Okay, that's gonna cancel everything out on the right hand side, but whatever we do over there, remember, we have to do over here. So we're going to divide both sides again by 900 joules per kilogram degrees Celsius times 61.8 degrees Celsius. Okay, so this canceled out 900 joules per kilogram divided by 900 joules per kilogram. That cancels all that out. 61.8 degrees Celsius divided by 61.8 degrees Celsius cancels that out. So our mass is now isolated. So we've got all of this, just all this math to do here. Divide all these things. Okay, we can cancel our units that we have. Kilograms on the top, kilograms on the bottom, joules on the top, joules on the bottom. Okay, degrees Celsius, top and bottom, degrees Celsius here and here, and we're left with our units of kilograms, which is the mass. So we have 4 times 4,184 times 3.2, divide by 900, divide by 61.8. 4 times 4,184 times, what was it? Our temperature difference was 3.2. And we're going to divide by 900 times 961.8. Hold on. That doesn't look right. No, can't do that. So 0.963, 0.963, 0.963 kilograms is our answer. 0.963 kilograms. And that's how you do that kind of a problem. Again, that's an A problem. If you guys have questions on this, make sure you ask. You've got an assignment to submit all these in. There is a submission page for all this, but email me if you have questions.